Hello, everybody. My name is Masood Olia, and I'm a professor in School of Engineering at Wentworth University. And I'm here with another video related to the topic of subject of dynamics and the topic of gear ratio, kinematics of rigid bodies. I really appreciate if you subscribe to my channel, and if you get something out of this video and you enjoy it, please like the video. Thank you. So what are we trying to do here? So you see this gear arrangement that we have here. We have this motor right here, which driving the gear A, and then gear A is in connection with gear B, and then gear B and gear C are having a common shaft. And then finally, this power or motion is transmitted to gear D. So we know the input coming from the motor. So if, assuming that omega of gear A or omega of the shaft coming from the motor is 20 radians per second, in whatever direction, really, it doesn't matter in this case. An angular acceleration of gear A, and that's also coming from the motor, is 4 radians per second squared. Then our objective is to, what is the output motion, meaning what is the angular speed of gear D and angular acceleration of gear D. So this is extremely simple problem, quick, easy problem. And I have other videos. If you search look under the playlist of dynamics, you'll find that a bunch of videos on gears and belt, which is basically the same thing. So you guys know that the relation, for example, look at gear A and gear B. By matching the velocity right at the contact point, and velocity being r omega, you could say RA omega A is equal to RB omega B. And that's where the gear ratio equation comes from. So if you say you want to find omega B, you say omega B over omega A is, you see how you have RA over RB, which is the inverse relation, meaning that the smaller the gear, the faster it rotates. The larger the gear, the slower. So in this case, gear B being larger, it has a radius of 100 millimeters. Gear A has a radius of 40 millimeters. So that means gear B is going to, its speed is going to be slower. So you see here, I'm going to solve for omega B. That's going to be RA over RB times omega A by just rearranging. So notice that RA is 40. And really, the rate, it doesn't matter if it's millimeters or meters, it's a ratio over 100 times the omega that is given. So in this case, omega B becomes 8 radians per second. So we could do the same thing for alpha. It's the same exact relation. You match the tangential acceleration at the contact point. So tangential acceleration being R alpha. So you could say again, RA alpha A equal RB alpha B, right? So you could do exactly the same thing and say, oh, you want to find alpha B, that would be RA over RB times alpha A. So it's the same ratio again, 40 over 100, and the angular acceleration being 4. So we end up getting 1.6 radians per second squared. So now, having determined angular velocity and acceleration of gear B, now notice that gear B and C they have a common shaft, so they're rotating with the same exact omega and alpha. So this is true for what? So we can conclude that actually angular velocity of C is the same as angular velocity of B, which is 8. I want to make sure that everything is in the same page, so you have the picture in front of you. So that's why I'm trying to squeeze everything here. So alpha of C is also the same as alpha of B, which is 1.6. Okay, now let's do the one last gear ratio relation between C and D. Remember, our objective is to find angular velocity and acceleration of c. So the same relation. So you see, if you want to find omega d, do a ratio of RC over RD times what? Omega c. See, exactly the same thing that we did here, right? RD omega d equal RC omega c, matching the speed at the contact point, right? So let's go ahead and find omega d. Omega d becomes what? RC is 50 millimeters and RD is 100 millimeters. So basically the ratio is 1 to 2. So omega c was 8. So actually this becomes what? 4 radians per second. So our omega d becomes 4 radians per second. So we started with an input of actually 20, and we reduced the speed to 4 radians per second at the output. And now same story with alpha d. Alpha d is RC over RD times alpha c. Remember, again, we are matching what? Yeah, tangential acceleration, right? So alpha of d becomes what? Again, the same ratio, 50 to 100 times 1.6. So this becomes 0.8. Unit is radians per second square. Okay, as I said, this is going to be an easy, quick problem. Again, I appreciate if you subscribe to my channel. I have videos on different topics: statics, dynamics, mechanics of materials, system dynamics, and vibrations. And I have different playlists. Okay, thank you for watching this, and we'll see you soon.